This project focuses on assessing potential impacts of energy sprawl on Minnesota landscapes due to ethanol production. Global concern over climate change is quickly growing. The Convention on Climate Change Conference took place in Paris November and December 2015. This event was a staging ground for world leaders from 43 major countries to come together and discuss the problems of pollution and rising global temperature. The conclusion of this conference was a groundbreaking agreement to aim to keep global warming below 2 degrees Celsius. This marks the first major United Nations agreement to mitigate the negative effects that humans are having on the environment. With countries looking to reduce their CO2 emissions, many are looking towards renewable resources in order to meet their individual renewable energy targets. Renewable resources such as solar, hydro, wind, and biofuels are gaining increasing weight within today's world of energy production. However, each renewable resource comes with its own costs and benefits. Take hydropower, for example. It is an incredible source of clean energy, but drastically alters the flow and ecosystem dynamics of a river, causing for negative effects such as habitat fragmentation and flooding. In our presentation, we plan to focus on biofuels as a possible alternative, and more specifically, corn grain ethanol. Corn grain ethanol has been proposed as a cleaner version of gasoline. Some of the benefits of corn grain ethanol include the fact that it could reduce our dependence on foreign oil, as well as decrease gasoline prices in general. The U.S. is actually the largest producer of corn, with 88.897 million acres of corn produced in 2015. When it comes to corn grain ethanol, some of the most influential factors are the policy, politics, and government subsidies that surround it.
So there's quite a bit of momentum behind corn grain ethanol, and that kind of all started with the Energy Policy Act in 2005, which put forth a renewable fuels mandate that required 15 billion gallons of ethanol to be produced by 2015 in the U.S., as well as 7.5 billion gallons of renewable fuel to be blended into U.S. gasoline by 2012. And for that first goal, 2015, we came up a little bit short and got 14.8 billion gallons of ethanol produced annually, but it was pretty close. And more momentum behind ethanol came from the Food Conservation and Energy Act of 2008, which was a farm bill that specifically endorsed and supported biofuel production from agriculture. Some of the provisions covered production, marketing, and processing of biofuel feedstocks, and this one really just kicked ethanol in the right direction. And after that, there was the Agricultural Act of 2014, which was a farm bill that succeeded the Food Conservation and Energy Act. This is the most recent bill. This farm bill covered research and development of renewable energy projects, such as wind and solar, but the main focus of this bill was to promote biofuels in the U.S., specifically corn-based ethanol.
A huge factor to this issue is the increase of energy sprawl. This is the product of the total quantity of energy produced annually and the land use intensity of production. A few of its negative effects include disturbed land, greenhouse gases, habitat fragmentation, and the inefficient use of land.
So to get a deeper grasp of biofuels in general, we decided to read some scientific articles about it. This first one, titled Land Clearing and the Biofuel Carbon Debt by Joseph Fargione, focused on alternatives to petroleum by increasing the production of biofuels, specifically corn, sugarcane, soybeans, palms, things like that. And basically, the point of the article is by using fire and digging up native habitats to convert to croplands, the general tilling of the soil creates CO2 emissions because there's carbon in the soil that get released into the biosphere. And the first 50 years of this process is known as the carbon debt. And over time, biofuels as an alternative energy source can repay this debt. But with the growing threat of climate change, it's just not really a good idea because 50 years is quite a long time. So here's a graph of the estimated land use intensity by 2030. This is in kilometers squared per terawatt hour per year. As you can see, ethanol from corn is just significantly larger than all of these other alternative energy sources, and so that's just another bad rap for ethanol in terms of land use intensity.
So here's another scientist's perspective. This article discusses the effectiveness and efficiency of ethanol when compared to biodiesel. Overall, ethanol yields 25% more energy than the energy invested in its production, whereas biodiesel yields 93% more. And with ethanol, CO2 emissions are reduced by 12% when compared to fossil fuels, and with biodiesel, CO2 emissions are reduced by 41%. Another topic to discuss when looking at this issue is the food gap. If we use valuable agricultural land to grow fuel instead of food, we may have problems feeding our growing population. Our research question was, what is the efficiency of corn grain ethanol in regards to land use? To find this out, we created a GIS model that sacrificed all Minnesota land capable of growing corn in order to determine how much of the U.S. gasoline demand the state of Minnesota could supply. This is a map of Minnesota corn in 2014. We knew that Minnesota grew 1.18 billion bushels in 2014, so we did a little bit of math and calculated that out to be 2.31 billion gallons of gasoline per year, or roughly 1.7% of the United States' yearly gasoline needs.
Here you can see a simplified image of our GIS model. We decided to make Minnesota our area of study because it's an area that we are familiar with. Our data inputs include a 30-meter raster digital elevation model and where corn was located and grown in 2014. Next, we set environmental constraints and built environmental factors, which are the areas where we deemed it impossible to grow corn. These areas include water, areas that are too steep for agriculture, and areas of high, medium, and low intensity development. After combining all of these factors, we were able to locate all areas within the state of Minnesota where we can grow corn. This leads us to our heroic or sarcastic corn estimate.
And ta-da! Here's our heroic corn map. As you can see, we're growing corn in pretty much every part of Minnesota. If it's not water, cement, or a mountain, we're going to grow corn on it. We calculated this out to be 8.21 billion bushels, which eventually ends up being 16.11 billion gallons of gasoline, or only 12% of the United States' yearly gasoline needs. In conclusion, when thinking about corn grain ethanol, or really any energy source, various externalities must be considered. These externalities are energy sprawl, increased greenhouse gas emissions from land changing processes, the food gap, and low energy efficiency. No matter the resource, the costs and benefits must be accounted for.
In addition to our conclusion, this is a list of other technology and resources that could be potentially some viable alternative energy sources, such as wind turbines, solar panels, low input, high diversity grassland, soybean biodiesel, hydroelectric, or geothermal. Thanks for watching.